first, does this series diverge or converge? So as soon as you notice the -1 factor, we know that it's alternating. You should be thinking alternating series test. So the limit as n approaches infinity of our terms is 0. Second check. Eventually, will all of our terms be smaller than the terms in front of them? Clearly, this is true always for all n greater than or equal to 1, because this denominator is always bigger than that denominator. We don't have to show that. It's so obvious. All right, so we know at this point that this series definitely converges, and we communicate that by the alternating series test, our series converges. Now, does the series converge absolutely or conditionally? Next step. And this is the definition. Our series, which converges absolutely if the absolute value of the terms as a series also converges, and conditionally if the series with the positive terms diverge. So how can we test that? So the absolute value of this term is basically a p-series. The absolute value is just the absolute value is just that. We identify this as a p-series. We identify the p-value as 1/2. We compare that to 1. We draw our conclusion, therefore diverges, and now we have our answer. Our series converges just conditionally. That's how you do those.